तुम्ही जी प्रॅक्टिस करायची टेबल पाठ करा, बाकीचं काही नाही. Okay, hello friends. It is a vibration mode calculated by using the symmetry criteria or symmetry concepts. So I consider the first example related with the C2V point group. Related with the C2V point group. So all these are examples. Water molecule, hydrogen sulfide, SO2, Cl2O are belong to C2V point group. So for explanation purpose I have considered the water molecule. It is H1, H2, and through this particular there is a Z axis is there. Then by using formula we can calculate the total number of vibration. So for polyatomic molecule the total number of mode of vibrations are 3n minus 6. For linear molecule the mode of vibrations are 3n minus 5. So here I have considered the total vibration 3n minus 6 because it is a polyatomic molecule, not linear molecule. So 3 atoms are there, H1, H2, 2 hydrogen and 1 oxygen. So 3 multiplied by 3 minus 6 is there. So 9 minus 6 is equal to 3. Means actual mode of vibration in C2V point group. Whatever example is there, it has the 3 vibration mode. 3 vibration mode. Now we have to find out the reducible representation. For that purpose, so I have considered C2V. The symmetry elements operations are identity C2, then sigma V X Z is a molecular plane just like C2. It is a sigma V, it is a YZ plane is there. Now if we consider number of unshifted atoms, if we carry out the rotation and based on that you find out the number of unshifted or unshifted or unchanged atoms. So if we perform identity, all 3 remains unchanged. So I have written here 3. If we carry out the rotation at 180 degree, so oxygen remain as it is and hydrogen are exchanged. So unchanged atoms are 1. If we consider the molecular plane, this is a molecular plane. If we carry out the reflection in the molecular plane, all remains unchanged. So it is 3. If we consider the YZ plane, so it is like this. YZ plane is just like your C2. So 1 oxygen remains unchanged and 2 hydrogen are exchanged with each other. So I think you understand this particular concept, number of unshifted atoms. So under identity all are unshifted 3. When you carry out the C2 Z rotation, then only oxygen is unshifted, 2 hydrogen are shifted. If we consider the sigma V X Z is a molecular plane, so all 3 remains unchanged, so 3 is there. And if we consider the YZ plane, so it is just like your C2, so again 1 remain unchanged. Now another concept is contribution to total character by each unshifted atoms. So here if we consider this particular table, so by using this unshifted atom contribution can be calculated. So under identity the 3 is the contribution to the total character by each unshifted atom is again 3. Okay. Then C2, so I have to consider C2, it is Cn. Okay, you consider it as a C2. C2 is equal to 1 plus 2 cos, C2 means 180. Okay. Cos theta म्हणजे theta we have to substitute the value of C2, C3, C2 means 120, 180, okay. Then 120, 90, 72, 60, these values are there. So here C2 is nothing but the 180 angle. So I have to solve this equation. C2 is equal to 1 plus 2 cos theta. Okay, you should consider this cos theta. So it is the value of your, it is a minus 1a. Okay, minus 1. Okay, so cos theta is 180, sorry. It is a, sorry 1. Okay, it is a minus 1 is there. So 1 plus 2 into minus 1. So it becomes 1 minus 2. Okay, so is equal to minus 1. So it is a minus 1. So I do use this concept for what purpose? Contribution to total character by each unshifted atom. So I do substitute the angle and solve equation, we get this particular value. So I think you understand minus 1. How it is 3? So directly straightforward here. Under identity, it is a unshifted atom. Character contribution is 3. Then for C2, it is a minus 1. Okay? In this way, C2 is equal to 1 plus 2 cos theta 180. 1 plus 2 into cos 180 value will be minus 1. So 1 plus 2 into minus 1. 1 minus 2 is equal to minus 1. So I have considered this as a minus 1. Now sigma V, it is a sigma. Okay, straightforward value is the 1. So I have considered it is 1, and again it is sigma V, it is also 1. Okay, these are the unshifted atom. These are the contribution of the unshifted atom calculated by using these two tables. Then third point is total character of the representation of which the vibration form the basis. Total character of the representation of vibration form the basis. Form the basis. You take the multiplication. 3 multiplied by 3, it becomes 9. 1 multiplied by minus 1 becomes minus 1. 3 multiplied by 1 becomes 3. 1 multiplied by 1 becomes 1. So it is a total character of representation of which the vibration form the basis. So I have to take the product of number of unshifted atom and contribution to the total character by each unshifted atom. Then you use the reduction formula. So by reduction formula, that is A of I is equal to 1 upon H, summation of chi r multiplied by n multiplied by chi j r. You find out the value of A1. The character table आपल्याला दिलेला असेल, त्यामध्ये character table is provided in question paper. If long questions are asked, it is asked for 6 marks. So you will solve by reduction formula. By reduction formula and character table for C2V point group. So A of A1 becomes 3. You solve it at home. A of A2 becomes 1. Means it is directly. Okay, A of A1 is it is a 3, it is 1, it is 2, and it is again the 1. So these are the values. Means A of A1 is 3, then A of A2 is 1, A of B1 is 2, and A of B2 is again 3. So these are the values for irreducible contribution. A of A1 is 3 times, A of B2 is 1 time, then A of B1 is 2 times, and A of B2 is 3 times. Okay, so by using reduction formula, you solve it, so we get these particular values. Which values? 3, 1, 2, and again 3. Okay, therefore the total vibration modes is equal to total vibration modes is equal to, you add it, it is a 3 times A1, okay, then 1 times A2, 2 times B1, and again 3 times 3 times B2. Okay, so you just add it. So total vibration mode is equal to 3A1, A2, 2B1 plus 3B2. Okay, up to this. The next step is that the total tau rotation plus translation, why to subtract. Okay, here rotation plus translation. So here again, why to subtract how many? So why to consider the character table, from that character table area number third, why to refer, and from that if we consider the rotation and translation, so why to subtract the two mode, so only one, sorry, why to subtract the one mode, and here only one mode remain as it is. So 3A1 you subtract A1, you subtract A1, so here 2A1 is remain. Okay, then again we have to subtract one mode, so it becomes 0. Okay, then again you subtract 1 B1, so 1 B1 is remain. Okay, and again it is a B2, again we have to subtract. So 3 all actually in area number third of character table, no any character is there, and that's why it is 0. So if we consider answer is 2A1 plus B1, it is a singly degenerate, means it is a 2 multiplied by 1. Again it is singly degenerate, so 1 multiplied by 1 is equal to 3, and total modes are 3. Okay, so it is a logic, it is a concept by which we can find out the total vibration modes. Why to subtract the rotation and translation, form irreducible representation by using the character table area number third. By using that particular case, actually we R, X, R, Y, R, Z are there. If you remember the area number 3, okay, there are X, Y, Z and RX, RY, RZ is there. So I have to subtract that particular thing, from that rotation. If X is there, we have to consider the translocation, and if you carry out this, so we get generally this particular the point. So remaining are subtracted, so total rotation and translation is subtract. So here 1 is there, so 2A1, here it is a 0, here it is a 1 is there, B1, and here again 0, no any quantity there, and that's why all are imitated, and total 2A1 plus B1 is the answer. A1 is singly generated, okay, A1 is singly dimension under character table for A1 is 1, so that's why 1 is there, 2 multiplied by 1, and B is again 1. So actually 3 modes of vibrations are there. So okay, so it is a symmetry criterion. It is a symmetry criterion for calculation of total mode of vibrations. Okay, so today I can stop here. Tomorrow, day after tomorrow, I can take the NH3 example, means C3V point group. Number of examples are there: ND3, arsenic, trihydride, antimony trihydride, BIS3, PCl5, PCl3, all these examples belonging in the point group C3V. So total number of vibrations are 3 and minus 6. It is a polyatomic molecule. N is again 4, 3 multiplied by 4, it is a 12 minus 6. So 6 modes are there. So in next lecture I can take this particular example. So there are actually 4 examples are there, so I can explain them. So in next video I can again explain how it is calculated. Okay, so okay, thank you. तर कॅरेक्टर टेबल असं तुम्हाला इकडलं असतं ॲक्च्युली माझ्याकडे नाही